For our first example, we are going to find the phase shift of f of x equals 2 times cosine of 2x plus 5 plus 1. Now, I just did a video on why the phase shift is the way it is. Yes, we learned that the phase shift is negative c over b, but for me there's an even easier way without having to figure out what c and b is. Now, for example, in this case, we know here's our c value and here's our b value, but for me, intuitively, all you need to do is set what's in the parentheses equal to 0, since that will determine the x value that gives you your initial y value. So it's easier for me to do this than it is to remember negative c over b. So just set what's in those parentheses equal to 0 and solve for x. If we subtract 5, we get 2x equals negative 5. Divide by 2, divide by 2. And we get x equals negative 5 halves, which equals negative 2.5. And a lot of times I just put PS for phase shift. So final answer for this one, the phase shift is negative 2.5. Now we will take a look at the graph just to confirm that it shifted negative 2.5 units from its starting initial value. This one's a little bit harder to see, but definitely you can still see it. So the gray function is the initial function cosine. We can see that the crest of the wave at 0 is obviously at 1. The new function, 2 times cosine of 2x plus 5, if we move negative 2.5 to the left, we see that this confirms that the crest of the wave is at negative 2.5. So again, that's what phase shift represents. It represents how many units it shifted to give you the new crest of the wave, or the new initial y value. It has to do with the shape of the graph, right? Because we can see the new one is a little bit skinnier, but still that crest of the wave starts at negative 2.5. That's it for this example of finding the phase shift of this function. If you have any other questions about it, let me know.